Welcome back, ladies and gentlemen. We're talking about 3.5 day 2 trig functions. We're going to be solving problems involving derivatives of those trig functions we talked about in the previous lesson. Alright, first of all, what is the equation of the line tangent to y equals 2 cosine x at x equals 3 pi over 2? Okay, well, if I'm talking about a tangent line, I'm talking a line with the exact same slope as the curve at that particular point. So, again, if I'm going to do that, I want to know the derivative. Okay, the derivative of 2 is of course 0, so I'm not going to bother writing that. And I've got a negative sign, and then derivative of cosine is negative sine. No pun intended there. And cleaning up that mess, I get sine x. Okay, now what I really want to know is the slope at x equals 3 pi over 2. Okay, and remember that the slope is the same thing as the derivative, so at this point I'm really saying m equals the sine of 3 pi over 2. And because we all expertly remember our unit circle, 3 pi over 2 is right down there, so our sine value there is negative 1, so our slope is negative 1. Okay, well, I've got the slope, I also need a point. Well, so the point is what we're going to get by plugging our original x back into the original equation. So now we've got y, again not y prime, regular y, equals 2 minus cosine of that 3 pi over 2. Okay, and again, thinking of our unit circle, same exact location of course, same value. Now, but cosine is 0 there. So y equals 2 minus cosine of 0 is 0. So y equals 2. And basically what that gives us is the point 3 pi over 2, comma 2. Kind of a messy point, but that's the one we have. Make sure that looks like a parenthesis. Alright, and for space concerns, I'm going to do the equation on the next slide. Okay, at this point I have recopied the relevant information we need to write the equation. Of course, plugging that into our point-slope form now, we've got y minus our y, which is 2, equals negative 1, which is our slope, minus our x coordinate, which again is a fairly messy 3 pi over 2, but we can deal with it. We're cool like that. So y minus 2 equals a negative x, then plus 3 pi over 2. And now granted, this is not the nicest computation we've ever done, but adding 2 to both sides here, okay, again, think of that 2 as a 4 over 2, so we have a common denominator. And so now what we get is y equals negative x plus, kind of smashing that all together into one whole thing, gives me 3 pi plus the 4 denominator from my common denominator term over our common denominator of 2. And so yes, it's messy, but there's our actual equation. Alright, of course, if you wanted to kind of get a rough decimal for that, that guy is approximately 6.712, but of course since it has a pi in it, it's actually a decimal that goes on forever. But there you go. Alrighty, this problem on the surface looks fairly similar to the last one, but there's a few important differences that I'm going to take the time to do to help point out. First of all, what's the equation of the line normal? Okay, now the word normal is a synonym for perpendicular, so don't freak out when you see the word normal. To y equals x sine x at x equals 5, and we're going to be rounding in 3 decimal places in this one, so that's one of the other things I'm going to point out, that we're going to have this very messy thing because we're given an x value that, granted, that's 5, and normally that doesn't seem bad, but if you think about it, I'm going to be plugging it in at some point to this x here, and there is no degree symbol attached to it, so it's definitely a radian value, which doesn't have a pi in it, so I'm going to get a very, very messy trig value here, which is why we're going to go with the decimals. Okay, but first thing first, let's get the derivative, because of course the derivative is the slope. And here we go. Now the other bad news is I've got a product here, so I have to use the product rule. Okay, so I'm going to take my first thing, which is the x, times the derivative of sine, which is cosine, and add to that the derivative of the first, which is just x, times the second guy, which is just sine. Alright, so that's my derivative, not ridiculously bad. But now what I want to do is plug in x equals 5. So at x equals 5, we get y prime, or the slope, interchangeable, 5 cosine times 5, or not times 5, of 5, plus sine of 5. And punching this in our calculator gives me a slope of roughly 0.459 and a whole bunch of decimals. But realistically, I don't care about that because I'm trying to go perpendicular. So what I want is the slope perpendicular to that, so I'm going to take the reciprocal of this guy and change the sign. And by doing that, I get something roughly 2.177. Okay, again, I'm rounding, so that's just messy, but actually I'm not rounding yet because I'm going to save that in my calculator. But here we go. Now, of course, we need to get the point, so I'm going to go back to my original, y equals, okay, plugging in my 5 into here gives me 5 times the sine of 5. Again, very, very messy sort of thing as I punch this in, but I get a y value of roughly negative 4.795. Alright, so I have a point, very, very nice 5, very, very messy, negative 4.795. Okay, and I don't know if I'm going to quite squeeze this in here. I'm going to skip to the next slide to do the rest of it. Again, here's my relevant information. So, of course, I go to my point slope form now. So, y minus my rather icky y, 4.795, equals the slope of my perpendicular, or normal, 2.177, times a very, very nice looking x minus 5. Alright, so of course we just clean it up as per normal, but we just have messy numbers during the cleanup process. And so distributing here gives me a negative 2.177x, that's the easy part, but then I get a plus 10.884, and then of course subtracting my 4.795 gives me a final answer of y equals negative 2.177x plus 6 point something like 089. And there you go. Alright, moving on to a nice physics sample for those of you who just love physics, or those of you who don't love physics, but here it is anyway. Alright, so we're given some position function of a body, and it's got a trig part to it, so 4 plus 3 cosine t. And we want to find the velocity, the speed, the acceleration, which we've all talked about, and we're going to find something called the jerk. Okay, now, don't freak out, I'm not trying to insult you or anyone else, but basically the jerk is, well, I'm sure you've all experienced this in a car. When a car comes to a stop, it kind of like rocks back and forward and jerks around a little bit, and that's exactly what that is. The jerk is basically a sudden change in acceleration, and there's actually a physics term for it, and it's jerk. Alright, so anyway, doing all these, and in case it's not clear from what I already said, and I'll bet it's not, but you know, we've got velocity, which is basically a change in position, which is again akin to speed. Then acceleration is a change in velocity, which is then the derivative of velocity. Since jerk is a change in acceleration, jerk is going to be the derivative of the acceleration. Okay, that being said, we should be able to get all these guys figured out. Alright, so if I take the derivative by my position, I'm going to get my velocity, and that's going to be 3 times the derivative of cosine, so that's 3 times the derivative of cosine is negative sine, and so what that gives us is our velocity equals negative 3 sine t. Okay, speed's next. Well, speed is pretty simple. If I do the absolute value of velocity, I'll get speed. So in this case, I've got the absolute value of negative 3 sine t. And if you want to, you can clean this up a little bit, because I could actually kind of almost factor out the negative 3 as a positive 3. So I've got really positive 3, and then the absolute value. I still need to take the absolute value of sine. Okay, and in case you're thinking I broke some crazy rules or something like that by doing that, consider this. Even if I leave the sign in here, and whether or not it's plus or minus, I'll still multiply by a negative 3, and regardless, positive or negative, I'll still, take a positive value out of it anyway. So, long and short of it, I'm not breaking any rules by doing that. If you don't believe me, test some values, test the original, test my version of it, and see if you get the same thing every time. Alright, moving on. Acceleration. Alright, so again, I want to take the velocity derivative to get acceleration. And okay, going back to my velocity, carefully don't look at the speed for this, although they're not very dissimilar. Okay, so derivative of sine is cosine, and the negative 3 is just hanging around for that, so I've got negative 3 times cosine t for my acceleration, and that one I don't need to clean up. There you go. And then finally, if I take a prime, I get the good old fun to say jerk, and then the jerk in this case, I've got my negative 3, and then the derivative of cosine, as we've kind of already done in this problem, is negative sine. So again, that's one I kind of want to clean up a little bit. Jerk equals 2 negatives makes a positive 3 sine t. Alrighty, so there's all those things for time t. Alright, continuing on with this problem, part B is basically going to ask you to find those particular things that we just found in part A for a given time. So t equals 5, and basically, I'm not going to subject you to this, but just all you have to do is plug in t equals 5 into all of those previous equations we just came up with, and that'll give you your answers. So nothing too major there. Okay, then C, I actually kind of disagree with what the book does, and I think you'll like my version of it better than what the book does. Describe the motion of the body. Well, of course they won't give you this graph, but if you were to graph 4 plus 3 cosine t, well, of course, the center line ends up being 4, which is, of course, your shift, and then the amplitude is 3, so it goes up to 7 and down to 1, and, of course, cosine starts at the top of the curve and then just oscillates between those. Okay, if you look at the back of the book for the problem and the homework that's like this, it gives you what equates to probably 2 to 3 paragraphs worth of information about all of these various things, position, velocity, speed, acceleration, and whatnot. I will be satisfied with something of the sort of this guy starts at s equals 5, or actually 7. What did I say, 5? I don't know. It's 1 because of 5. Okay, and of course the starting point, okay, even if you didn't graph it, basically all you have to do is plug in t equals 0 and compute it and see what happens. But I also want you to understand how the graph would look. So it starts at s equals 7, position of 7, then it oscillates between, well, 7 and 1. And I'm fine with that. You don't have to write a 5-paragraph essay about all those other features. I'll be thrilled if you give me that much. Okay, that being said, that's the rest of the lesson. Hopefully it made sense as always, and otherwise I'll see you in class.